Yes, it's kind of a sad moment. We've reached our 7th and final help video. Over our test premiere for Unit 8, 8-20, where we had 25 objective questions to answer. And we're down to our final help video. This video will discuss questions number 24 and 25. Let's get after it. The following equation describes the reaction for the formation of dinitrogen monoxide, commonly called nitrous oxide, an aesthetic used in dentistry and surgery. So we're looking at the reaction right here. Ammonia, NH3, reacting with oxygen to form N2O, dinitrogen monoxide, called nitrous, and the other product is water. What kind of reaction is this? Which of our 7 types? Well, it's certainly not synthesis because we have more than one product. It's not decomposition because we have more than one reactant. It's not single. The left side of this looks like it's single displacement or replacement. Compound, element. But on the right side, if it was single, we should have compound and element. Oxygen would have to replace one single element in ammonia, and it didn't. So it's not single displacement or replacement. It's not double, because double is where you have the first element in a compound replacing the first element in the other compound. They trade places. No. We don't have 2 compounds. We have compound and element. Is it a combustion reaction? We have oxygen here. We have water here. Well, it's not a pure combustion of a hydrocarbon. It's not a pure combustion of a hydrocarbon. So we're not really going to treat this as a combustion reaction. Although if you look at it, it looks very similar to a combustion reaction, except our other product is not CO2. It is water. It's not acid-base neutralization. We do have water, but N2O is not a salt. Acid-base neutralization reaction, we have an acid and a base. We don't have an acid over here. And on the product side, we do have water, but we don't have a salt. It's oxidation reduction, which gets us to the first question. What substance undergoes oxidation? What's going to undergo oxidation in this reaction? Oxidation involves the substance. If you remember oxidation, oil rig, oil is oxidation is loss of control of electrons or loss of something negative. If you lose something negative, your number is going to go more positive. So the substance that's undergoing oxidation should have an increase to its oxidation number. Let's take a look at nitrogen here first. Nitrogen is with hydrogens here. Nitrogen's our third strongest electronegativity. When hydrogen is with nonmetals, it's going to be a minus, or it's going to be a plus. When hydrogen is with metals is when it's minus. So hydrogen's with a nonmetal, it's going to be plus. The nitrogen's -3. There's one nitrogen for -3. The hydrogens, when they're with nonmetals, are +1. We have 3 hydrogens at +1 for +3. The numbers make sense. -3 and +3 is 0. So nitrogen gets to be its -3. They all make sense. So nitrogen starts off at -3. Over on this side, though, nitrogen is now with oxygen. Oxygen's the second strongest electronegativity at 3,5. So here it gets its -2. We have one oxygen at -2, so the total minus is -2. N2O does not have a charge, so the number should add up to 0. That means nitrogens must add up to +2. We have 2 nitrogens that have to add up to +2. That means nitrogen must be +1. Each nitrogen's +1. So nitrogen started out at -3 and it ended up going up to +1. That's what oxidation is called. Nitrogen is oxidized. So what substance undergoes oxidation? The nitrogen does. If nitrogen is being oxidized here, that means this compound, the substance that contains the thing being oxidized, is the reducing agent. Let's take a look at what happens to oxygen here. Oxygen is in elemental form here. In elemental form, you can't control another's electrons. You're equally strength. So oxygen starts out at 0. Here it's with nitrogen, so it's a -2. Oxygen gets its number. Oxygen's in family 6. It needs 2 more electrons to get 8. It gets its number of -2. Oxygen's the second strongest. When hydrogen's with another nonmetal, that other nonmetal is going to get its charge. It's -2. So oxygen went from +0 down to -2. Its number was lowered or reduced. Its number was lowered or reduced. Oxygen was reduced here. What does that mean? Well, the substance that contains the thing that was reduced is called the oxidizing agent. The substance that contains the thing that's reduced is the oxidizing agent. That's where the term oxidizing agent came from, the element oxygen, because oxygen is famous for being able to get reduced in a reaction. It's famous for gaining control of electrons in reactions. So the substance that gets reduced is called the oxidizing agent. In other words, oxygen gains controls of other things' electrons by oxidizing. It gained control of nitrogen's electrons. It oxidized the nitrogen. The reaction above is oxidation reduction reaction, number 25. We're on 25 now. The reaction's oxidation reduction. Yes, we have things being oxidized. We have things being reduced here. Is oxygen the oxidizing agent? Yep, we just talked about that. Oxidizing agents contain the thing that was reduced. Oxygen is reduced from 0 down to -2. The name oxidizing comes from oxygen, because oxygen is famous for getting reduced. Rig means reduction is gain of control. Oxygen's great at controlling. It does it by oxidizing other substances. Thus, the term oxidizing agent came from oxygen. Ammonia is the reducing agent. Well, we labeled it as such. Reducing agent is ammonia. Reducing agent contains the substance that is oxidized. Nitrogen's oxidized from -3 up to +1. Nitrogen gets oxidized. The substance that has the thing that is oxidized is called the reducing agent. True. Number 3, this reaction is single displacement or single replacement. No. The pattern of single is element and compound. An element replaces another element in a compound. That didn't happen. Up here, we have compound and element, but we end up with compound and compound. Oxygen didn't replace things. Oxygen joined the nitrogen. Oxygen joined the hydrogen as well. It didn't replace anything there. So this reaction is not single displacement or replacement. It doesn't fit that pattern. The pattern is always element, compound, when it's single displacement. This pattern is compound, element. That's not single. Letter E, the stock name. We already know D is false, but let's just double check D. The stock name for N2O, we called it dinitrogen monoxide. It's sometimes called, as we saw up here, it's sometimes called nitrous oxide. But here, they're saying it's called nitrogen 1 oxide. When they give the stock name, in the Roman numeral, they're given the oxidation number of the first element. So we come back up here, N2O. What is nitrogen's oxidation number? We already discussed it. It's +1. The oxygens get their number of -2, which means the nitrogens must add up to +2. We've got 2 nitrogens adding up to +2, meaning 2 divided by 2, each one is 1. The stock name would be nitrogen 1 oxide. That ends our 7 help videos for 8-20, our test premiere. the objective part, 25 questions. If these help videos still leave you confused, please email me. We can set up a meet to go over any of the questions that you have. We can make additional help videos, or we can merely chat back and forth by email. But if you're having trouble with any of this, this is a great summary of the things we learned in Unit 8. If you're having trouble with any of the things we learned in Unit 8, just fire me an email. Thanks for watching. I hope you're having a great week.